Hello and welcome everyone. This is Noah, and in this video we are going to look at graphing quadratic functions that happen to have a greatest common factor in them. And we're going to be looking at an example for this to show you guys how it all works. All right, let's take a look at this example. It says to graph the following quadratic function, f of x equals negative 12x squared plus 9x by hand, or to find the vertex, the y-intercept, and the y-intercept's mirror. Then we're going to find the x-intercepts by factoring out the GCF and applying the zero product principle. Finally, we're going to find an additional point along with its mirror and plot those points as well. Let's go ahead and start with the vertex. We'll find all this information, we'll start plotting it. So for the vertex, we want to use that little formula, negative b over 2a, to find the x value of the vertex. So here we're going to have, for this function, let me just write this, f of x equals negative 12x squared plus 9x. We have a equals negative 12 and b equals 9. We also can say that c equals 0, but that is not going to come into play right now. So the x value of the vertex is going to be negative 9 over 2 times negative 12. Go ahead and simplify this down. This will be a positive 9 over 24. And then we'll go ahead and reduce this. We've got 3 over 8 here. Not the most fun number, but I think we can make do. Let's see. I'll start getting the coordinate plane set up. So I'm thinking ahead about the scale I want to use for this. And I've got an x value for the vertex of 3/8. It's not the greatest number. I want to go ahead and not get too far into graphing anything yet. I want to find some more information. I think I want to find the x-intercepts and the y-intercept at the very least so that I can get a better sense of what my scale should be. So that's my thought process when I'm doing this. I'm like, okay, I kind of want to plot this vertex, but I kind of don't yet. So I want to find the y value of the vertex. To find that, we're going to plug the x value of the vertex into the function. So we'll get f of 3/8, and we'll get a little practice of some fraction arithmetic here. Everybody's favorite, I know. So I'm going to have negative 12 times 3/8 to the second plus 9 times 3/8. Simply keep in mind as we do this fraction arithmetic that nobody thinks it's everyone thinks it's a little bit more of a pain in the butt in order to have to deal with this fraction arithmetic. But fractions are numbers that we run into in math all the time. Instead of shying away from them, just say, okay, yes, this is going to take a little bit more time and effort, but let's just apply our fraction rules, go slow, not make any mistakes, and get our answer. And instead of sitting here and being like, oh goodness, how am I ever going to do this? We just need to start the process and get through it. So I want to square the 3/8 first. That's going to be 9 over 64. And then the 9 times 3/8 we can do as 27 over 8 straight away. All right, I'm going to go ahead and note that that 12 is over a 1, and this is multiplication. So I can reduce here. I can see that a 2 goes into both the top and bottom, so we can have negative 6 over 32. And it looks like we can put another 2 into these to get negative 3 over 16. So we can multiply those together now. Negative 3 times 9 is negative 27. And then we have 1 times 16 is just 16 on the bottom. And that doesn't reduce anymore, so I'm going to go ahead and multiply the 27 over 8 by 2, top and bottom. So this is going to give us 54 over 16. And we can now get that negative 27 over 16 plus 54 over 16 is 27 over 16. So even the y value of my vertex is a not fun fraction. Let's look at, well, let's start with the y-intercept and its mirror. The y-intercept, that occurs when x equals 0. So I say f of 0, and I note that that is going to be at just 0, right? So we have a y-intercept of 0, 0. So I can definitely plot that now. That's obviously right there at the origin. That's one of the points on the graph. And then for the x-intercepts, we want to set y equal to 0. So I'll say 0 equals negative 12x squared plus 9x. And here's the thing, we're going to avoid the quadratic formula now. Instead, we are going to factor out a negative 3x as a greatest common factor, because I want to pull that negative out of the front, and 3 goes into 12 and 9, and there's an x in both terms. When I do this, I'm left with 4x minus 3. And so if I apply the zero product principle, I get either negative 3x equals 0 or 4x minus 3 equals 0. And I can solve both of these to get x equals 0 or x equals 3/4 when I add 3 and then divide by 4 in that equation. 4x minus 3 equals 0. All right, this is nice because it shows me that this x-intercept is at 3/4, and I've got all of these fraction numbers. So I think in my x-axis, I really want to go by, like, I'm going to go by 16ths. So this is 1/8, and then 2/8 is 1/4, and then 3/8, and then 1/2, and 1, 2, 3, 4, 5/8, and then 3/4, and whoops, don't want to skew my scale. 3/4, 7/8, and then 1 would be out here. Okay, so my x-intercepts are 0, 0, which is also the y-intercept, and then 3/4, comma 0. So go ahead and label that point, 3/4, comma 0, and 0, comma 0. Get my x scale out here, negative 1/4, negative 3/8. I don't think we'll have to go any further than that. All right. In the y direction, we've got 27 over 16 as the y value of the vertex. So that's bigger than 1. And let's see, 32 over 16 would be 2. So this is close to 2. Not quite. If we do by 1/4. So this is 1/2, and 1, then 3/2, and 2 here. And so my vertex is at 3/8, comma 27 over 16. So I'm going to draw that axis of symmetry in. This is not part of the graph. This is just noting that the entire graph is symmetrical over this line. And we can see that the y-intercept's mirror point is the other x-intercept here. So we've already found that. That's part of this already. And I just need to find where is 27 over 16. So 1/4, this is this point here, this is 5/4. And then 6, this is 7/4. 7/4 is equal to 4 times 7 is 28/16. So we can see that 27/16 is just under that line right there. So here's my vertex at 3/8, 27/16. And then the problem says to find 2 more points, find an additional point along with its mirror. So I want to find something like where x is negative. I want to plug in f of, now there's no rule here, you could plug in a different x value. But I want to get something that's down in the bottom half here to help me graph this a little bit better. So if I plug in -1/4, I'm going to have -12 times -1/4 squared plus 9 times -1/4. And so this is going to be -12 times 1/16 minus 9/4. I can reduce this 12 and the 16. 4 goes into both, so this will be a -3 and a 4 on the bottom. So this will get us -3/4 minus 9/4 equals -12/4. Oh, this is a nice one. I wasn't sure how good this would be. So that gets us down to -3. Let's find -3 here. We've got -1, -2, and then -3 is going to be all the way down here. Cool. So I've got this point -1/4, -3 that I'm going to draw in, and then its mirror, I'm just going to go across the symmetry line here to find it. And so I've got 4, 8, 9, 10. So we'll go now 4, 8, 9, 10. Get this point over here, that looks like an x value of 1. 1 comma -3 here. And now we can draw a parabola through these 5 points. Alright, that's it. I'll label this y equals f of x as my final touch to this. And that is what we're doing here. I want to give you a little bit of relief. Not every problem is going to have these horrible fractions. They can occur. The now you try problem that you're going to be doing next does not have nearly so bad of fractions. If I look at that one just below here, it's 2x squared minus 6x. That's not going to be nearly so bad. So for the problem that you're about to try, I think you're going to find it's going to be a lot better. I think it's good for you to see these fractions and that we can deal with them. You know, go slow here. It gets real tedious when we have fractions, and finding our scale for the graph can maybe be the hardest thing about this problem here. So it's good to look at, though. It's good to improve those fraction skills. If you take nothing out of this class other than you've gotten better at fractions, I would say that that's at least a very small success, that you've become more comfortable with a kind of number that's a pain in the butt and a lot of people struggle with. And if you can use this as an opportunity to get better at them, then that's something that you should grab hold of. All right, that's enough of my little spiel here. Thanks so much for watching. I will see you in the next one where I walk through the solution to the Now You Try problem.